Okay, so this next group of problems is finding limits algebraically. Um, what you want to do first, your first course of action should be plugging in the value of x to see if you can just plug in and get a solution. If you can plug in and not get a 0 in the denominator, then that is your easiest course of action. That's almost not even algebra. That's just, working through the problem with arithmetic. Then, if that doesn't work, if you're going to get a 0 in the denominator when you put that value in, that's when you need to do some more algebra. So, let me actually get rid of a couple of these. We have too many on a page, and then we can work through them. Okay, that's better. All right, I'm going to start by plugging in 2 for the limit as x approaches 2 of this rational function. So I can drop my limit notation once I'm to the point of plugging in for x. So I'm going to do 2 plus 2 in my numerator, and 2 squared plus 2 minus 2. So I'm not getting a 0 in my denominator, so I'm in good shape here. 2 plus 2 is 4. In the denominator, I have 4 plus 2, so that's 6 minus 2 is 4. So my limit is 1. And you could, of course, verify that on your calculator. All right, number 4. On number 4, I'm going to do a little work first, because when I'm looking at this limit, if I plug in 2 to my denominator, I'm going to get a 0 in my denominator. And we don't want an undefined situation when we're taking the limit. So I'm going to keep the limit notation because I'm not to the point of plugging in. And I'm going to factor. In the numerator, I can factor out an x to start. Ooh, and then I have a difference of squares, which is lovely. And I'm going to keep the limit notation going because I'm not evaluating the limit yet, and that's important if you have equal signs in between. So I'm going to keep the x out front of the GCS, x squared minus 4, x plus 2, x minus 2. And that's going to let me cancel. So now I can cancel my x minus 2's, and now when I plug in the 2, I'm not going to have an undefined situation. So at this point, I'm taking the limit as x approaches 2 of x times x plus 2. And since I'm at the point of evaluating the limit, I can go ahead and drop that limit notation. So 2 times 2 plus 2. So 2 times 4 is 8. So the limit as x approaches 2 of x cubed minus 4x over x minus 2 is 8. So that would, you guys know from your work with rational functions, what happened here was this is a whole at x minus 2. Or I'm sorry, at x minus 2, which is x equals 2. Okay, let's do a couple more on the same video. So when I look at this guy, this looks like a mess. These next two are pretty complicated, or they look actually a lot more complicated than they are. So don't be scared off. The first thing I want to check is that what happens when I do cosine of 0. And cosine of 0, of course, is 1. So if I square that, I'm also going to get 1. So just double checking that lets me know I don't need to do any extra work to this. I can just go ahead and evaluate the limit by plugging in 0 for all my x's. So I have e to the 0 minus tangent of 0 over cosine squared of 0. And if you would rather write that as cosine of 0 squared, those are equivalent. And now we're going to evaluate. E to the 0, any number to the 0 power is 1. Tangent of 0, if you struggle with tangent, especially at the quadrantals, do sine over cosine. Sine at 0 is 0. Cosine at 0 is 1. Okay, so that's just going to give me 0. And then we talked about how cosine at 0 is 1. So that's going to be 1 squared in the denominator. So I'm going to end up with 1 minus 0 is 1. 1 squared is 1. So this limit that looks like a mess to start with is just 1. Again, don't be scared of those problems. You know how to deal with trig values, and you know how to deal with exponents, whether you're dealing with e or any other exponential. Another one not to be scared of. The limit as x approaches pi. Again, this looks like a mess, so I'm going to kind of take a little second to double check that I don't need to do any work before I take the limit. If I plug pi in right here, I'm going to get -1. 2 times -1 is going to give me -2, and then ln of e, if you remember, is 1. So my denominator is not going to be 0. I'm in good shape here. So let's plug in pi. So I have secant squared of pi 2 cosine squared of pi minus ln of e. And now let's put in the numbers that go with those. Well, cosine at pi is -1. And if cosine at pi is -1, then secant at pi is -1. So I'm going to have -1 squared on the top as well. Remember, secant is just the same as 1 over cosine. So this would really be 1 over cosine squared of pi. And ln of e is 1. Let's see how many 1s we can put in this problem for you. So -1 squared is +1. And the denominator, I have 2 times 1 minus 1. So again, this one also, that mess also comes out to 1. All right. Some limits algebraically. The next couple problems, you're going to have some algebra to do, lots of factoring. So if you haven't tried those yet, if you're waiting on the videos, take a pause, see if you can do some factoring to make those problems a little easier for yourself before you watch the video.